When we write a number in scientific notation, what we're really saying is that we're going to basically write a single digit, followed by a decimal, and then some more digits which represent the tenths, hundreds, thousands, and so on in a decimal number. And then that's going to be multiplied by 10 to some exponent. For example, 3.25 times 10 to the second. That's the scientific notation for 325. So let's now look at how we take a number and take it from being a regular integer like we're accustomed to and turn it into scientific notation. So supposing we have a number like 575, we're saying that that's going to be equal to a single digit, which will be the 5, followed by a decimal, then the remaining digits in the tenths and hundreds positions. That's going to be multiplied by 10, and then the exponent that we're going to put on there is going to depend on the number of decimal places that we had to move to get the decimal to where we want it to be. The decimal on the original number was here, and so it's moving 2 positions to get to where we want it to be. So that means we put a 2 as the exponent on the 10. Let's look at another example. 7,697. We want to convert that into scientific notation. So we start off with the 7, a decimal, and the remaining digits. We're going to multiply that times 10 to some exponent. We're moving the decimal place 1, 2, 3 positions. So that means we put a 3 on the 10. So 7.697 times 10 to the third is the scientific notation for 7,697. Now what happens if we start off with a number that has decimals in it already? So 4,392.421 in scientific notation. We always follow the same approach. We put down the first digit, followed by a decimal, and then the remaining digits, and then we multiply that times 10 to some exponent. The question is, what's the exponent? And we see we went 1, 2, 3 positions for the decimal. So that means the exponent on the 10 is going to be 3. So the process doesn't change at all, regardless of whether we have decimals on the original number. The key to keep in mind here is that we're always working in an equation. An equation means that things always have to stay into balance. Sticking with a simple number, if we've got a number like 4,000, that's equal to 4 times 10 to some exponent. You're probably familiar with the fact that 4,000 is equal to 4 times 1,000, and 1,000 is just 10 to the third. So to answer our original question here, 4,000 is equal to 4 times 10 to the third in scientific notation. Now, what happens when we've got a number that's smaller than 1? Supposing we've got a number like 0.12. What's that going to be in scientific notation? The process is almost exactly the same. We start off by putting in this first single digit, the 1, decimal, and then the remaining digits. In this case, there's only one more digit, so it's a 2. We're going to multiply that by 10 to some exponent. The trick here now is that we're not multiplying by a large multiple of 10. In fact, we're effectively dividing by a multiple of 10. But let's not worry too much about that. Let's just go through the mechanics. How far have we moved the decimal? We've moved the decimal point just 1 position. So that means we need just a -1 on the 10. So previously we were moving the decimal place to the left. Now, since we're moving to the right, it means we're putting negatives up here. Let's think about this a little bit further. In order to keep this equation in balance, if we've got 0.12, the real question is, what are we going to do to 1.2 to get it to equal this? The short answer is that we're taking that 1.2 and we're dividing it by 10. Dividing by 10 is the same as multiplying by 10 to the -1. So what if we have a number like 0.000426? Well, the scientific notation says we're going to start off with the 4, then put the decimal in the 26, and we're going to multiply that by 10 to some exponent. So the question now is, what do we divide 4.26 by in order to get 0.000426? Well, we're moving the decimal 1, 2, 3, 4 places. And since the decimal is moving to the left, that means we're going to do a -4 as the exponent. Another way of looking at that is 4.26 divided by 10,000. That's going to give you that same answer of 0.000426. One more example, 0.000000375. Process is still the same. We start with the first significant digit here, 3.75. Multiply that by 10, and then, well, what's the exponent? The exponent depends on the number of positions we've moved the decimal place. 1, 2, 3, 4, 5, 6. So 10 to the minus 6. Now, how do we connect scientific notation to the metric system? Suppose you had a number like 9.63 times 10 to the minus third meters. Remember, 10 to the minus third meters, 10 to the minus third is the same as saying take 1 and divide it by 1,000. So 1,000th of a meter is 1 millimeter. So when we see 9.63 times 10 to the third meters, what we're really seeing is that the 10 to the third meters, if we sort of connect those two concepts together, instead of connecting the 9.63 and the 10 to the minus third, we're connecting the 10 to the minus third with the units. By doing that, 10 to the minus third meters is millimeters. So that means what we've really got here are 9.63 millimeters. Let's look at another example. What if we had 4.35 times 10 to the third meters? 10 to the third is equal to 1,000. So again, if we just connect these two pieces together, 10 to the third meters is 1,000 meters, and 1,000 meters is actually a kilometer. So in fact, what we've got is 4.35 kilometers.